Okay, what we're going to talk about today is graphing translations of trigonometric functions. And this follows along with translations of the other function families that we have done involving h and k. So h being a shift left or right and k being a shift up or down. And here is an example of a horizontal translation, and that is when we have h subtracted from x, or added to if we have a shift left, in parentheses with the x value. And you can see that the whole function shifts over by h units, okay? Here is a vertical translation. So this is when we add a k value at the end of our function, and it shifts it up if we add k, down if we subtract k. So that is an example of a vertical shift. First thing that we're going to do here is go down to example 1. What is the value of h in this translation? So describe the phase shift. So would you agree it's in parentheses with the x, right? And it's added. So it is a horizontal shift, right? And it is a shift left, because plus is to the left, minus is to the right. So this is a shift left. 4 units, and h equals -4. All right, so we identified what h is, and we described the phase shift. So it shifted left 4 units. So let's just look at this word phase shift, and I'm trying to see if I left the definition. Here it is. Phase shift, a horizontal translation of certain periodic functions, all right? Special name. So now go down here, and we are going to graph some translations. And so, whoops, let me get that paper lined up there. Very faint graph, but it'll work for us. Y equals sine x plus 3. Now, when you're doing these, I find that the easiest way to do these is to graph the original function y equals sine x, and then shift it. So we know that when we graph y equals sine x, it's going to cross the x-axis there. So how about this? I will make this 1, 2, 3, and 4. And so down here is -1. So right there, right there, so that is our original y equals sine x. Let's label this. This is y equals sine x. Now, we have a plus 3. Is that an h or a k? Okay. That is a k. So we have k equals 3. Shift up 3 units. So when we do that, every single point here goes up 3 units. So here, this goes up 3, this goes up 3, this goes up 3, and this goes up 3. And so we're doing this all based on shifting our original sine curve. So you see there, and I'll label this guy. This is y equals sine x plus 3. Make sense how we do that? And I find that it's actually easier just draw the original sine function, and you can, since you're doing yours all in pencil, if you want to use a color to do it, or make it a dashed line instead of like I have mine as a nice light green. You can make it a dashed line just so it's there so that you can visually see how it's shifting. All right, let's do another one. So, we've got y equals sine x minus pi over 2. Do we have an h or a k?
H.
We have an h, and what is the value of h?
Pi over 2.
Okay, so this is a phase shift. Are we going right or left?
Right.
And we're going right pi over 2 units. So the first thing I'm going to do is draw my original sine curve in there. And this one, I'm going to make this 1, this will be 2, this is -1, this is -2. I'm just scaling it differently. So here, here, and here, there, and there. So I'm just going to draw this guy in here. So this is y equals sine x, and what we're going to do is we are going to shift this to the right, pi over 2 units. Now you see pi over 2 units is 2 tick marks, right? Okay, so 2 tick marks to the right, 2 to the right, 2 tick marks to the right, 2 to the right, and 2 to the right. Fair enough? And I'm going to draw this guy in. Alright, so this is y equals, let's make sure it's on the screen, sine x minus pi over 2. Fair enough? Shift right. Beautiful. Okay, so I have a little concept summary here for us in the middle of the page. Here's the parent function, y equals sine x, and y equals cosine x. Here's the transformed function. A, remember, in front, absolute value is your amplitude. Your B is used for your period. Your H is your phase shift or horizontal shift, and your K value is your vertical shift. And Y equals K is your midlines. I want to highlight this so that we know. Y equals K is your midline. All right, so we have a couple here that we can work on. So first of all, let's go down here to example A. What's my amplitude? It's 1, because you don't see anything there, so that coefficient at A value is 1. Okay, what is our period?
2. Oh, wait.
2 pi?
2 pi, because the B value that you don't see is 1. So your period is 2 pi over B, which is 2 pi. So period equals 2 pi. All right, what is our phase shift? Negative pi. So this is going to be left. And what is our vertical shift?
Just 2.
Vertical shift, K equals -2. This is down. Okay. Not for K. K is not the opposite. All right, so here's what we've got. Let's draw the original one in there. So I'm going to draw -1, -2, -3, -4, 1, 2, 3, and 4. So here, 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 and here is my basic sine function. So this is y equals sine x. Okay, let's talk about what we've got. Our period is 2 pi. Our phase shift is pi to the left. So would you agree we've got to go all the way over to here? And we also have to go down 2, right? So pi to the left and 2 down. Oops, I better use a different color here. All right? So that's going to be true of all my points. So I'm going to go pi to the left and 2 down, or I can follow this same path here. So pi to the left, which is 4 tick marks left and 2 down. And that's going to give me this. So this is y equals sine x plus pi minus 2. Okay, let's do another one. Okay, amplitude. Okay, period. 2 pi. Okay, phase shift.
2.
So this is to the right. And then we've got vertical shift. And what's our vertical shift? 3. So k equals 3. This is up. So once again, draw that basic sine curve or cosine curve. So here's that. Okay, so this is y equals cosine x. Now, from here, we are not changing our period, but we are shifting up and to the right. Now, it says 2 radians. So 2 radians, can I get you to agree, will fall right about in here, because this is 3, right? So it's going to fall right around in here. Pi divided by 2 is like 1.6 something, so it's going to fall right in here. Alright, so we're going to go that much to the right, and we're going to go up 3. So I'm going to go up 3, and that much to the right. So here I'm going to go up 3 and that much to the right. From here I'm going to go up 3 and that much to the right. From here I'm going to go up 3, that much to the right. From here I'm going to go up 3 and that much to the right. And here and this is going to be my new one. This is y equals cosine x minus 2 plus 3. And let's get it all on the page. There we go. All right? That's what this business is all about, of shifting. Yes?
Can you just please see me?
I cannot.
Oh, you can't.
No. Okay. Now, if you check out this particular one, notice we have a b value, right? All right? So what we're going to translate is not y equals sine x, but y equals sine 2x. And so we need to figure out, so this means our b is 2, and our period equals 2 pi over 2, which is pi, right? Okay. And this is sine, so if I make this, I'll make this 1, and this is -1. So starting right here, ending here, crossing there, up there, down there. So let me draw this guy in here. He's little. And this is going to be y equals sine 2x. There we go. So now we've got to go to this one. What's our amplitude? Whoops, let's get blue out here.
1.
Okay, what's our period?
5.
What's our phase shift?
To the right. H equals 1/3.
H equals pi over 3, and this is to the right. And vertical shift? So this is down. Okay, so let's go for our new graph. Okay, pi over 3 is right about maybe here. Can I get us to agree to that? Because this is pi over 4 and this is pi over 2, so pi over 3 is in the middle there somewhere, ballpark-ish. All right, so that's about how much to the right we're going to move. And we're going to go down 3/2 is 1.5, okay? So I'm going to go down 1.5, and I'm actually going to the right about in the vicinity of 1.5 tick marks. All right, so this one, down 1.5, over 1.5, somewhere over there. Down 1.5, over 1.5-ish. So down 1.5, over 1.5-ish. And last one, down 1.5, over 1.5-ish. And that gives me this graph. And this is y equals sine 2 x minus pi over 3 minus 3/2. Okay? Last thing we're going to do is we're going to write some functions if we're given the translations in words, which I think is fairly easy. So it says, what is an equation that models each translation? So we have a sine function, and it's going to move down pi units. So which variable is that?
Okay.
This is k. So if k is going down, then k would equal negative pi, right? Because down is negative. And remember, our basic function here is y equals a sine b x minus h plus k. Nothing else has changed. So can I get you to agree that this is y equals sine x minus pi, right? Okay, what about this one? 2 units to the left. What variable is that? H. And going to the left would mean, is it the 2 positive or negative?
Positive.
Negative, going to the left. But you subtract it and it makes it positive in the equation. So y equals negative cosine x plus 2. because it's minus negative 2.
Oh,